Hello everyone, my name is Zane. I am a volunteer with Earthburn, and this is lesson 3 out of 4 of the STEM lesson series. And for this lesson, we'll be focusing on engineering. So engineering is a very broad term and has tons of different jobs that you can do. But for this lesson, I want to focus more on the more uncommon types of engineering and also some of the responsibilities that engineers have. So these are 4 of the uncommon types of engineering, which are robotics engineering, energy engineering, agricultural engineering, and sports engineering. So robotic engineering design robots and robotic systems to help humans perform duties that they are unable or reluctant to complete. This is pretty similar to biomedical engineering. However, biomedical engineering is more on the medical side of things, but robotics engineering pertains to more of everyday life activities instead of medical circumstances. Then there is energy engineering. So energy engineering is really similar to chemical and environmental engineering. However, it is a lot more specific. And energy engineering will be a great major if you want to get into that. If you know for sure that you want to work with energy. However, if energy is just something that you're interested in, but if you're also interested in maybe like water or air quality, then degrees like chemical engineering and environmental engineering will be more beneficial to you than just energy engineering. So, energy engineering is concerned with the management and usage of sustainable sources like biofuel, wind, and solar power. So, as the world increasingly prioritizes sustainable energy supply, there's growing demand for energy engineers with roles in environmental and energy consultancies, the motor industry, charities, and the manufacturing sector. Then there is agricultural engineering. So, with this, you solve problems concerning power supplies, machine efficiency, the use of structures and facilities, pollution and environmental issues, and the storage and processing of agricultural products. Again, agricultural engineering is really similar to environmental and chemical engineering in terms of you are working with the environment. However, agricultural engineering is a lot more specific and you're mainly just working with agricultural products. So then there is sports engineering. This is probably one of the least popular types of engineering. So with this, you design the next generation of innovative sports clothing, equipment, and tracking devices. So with competition ramping up, both national and private organizations are investing huge amounts in ensuring their athletes have the fastest, lightest, most streamlined equipment possible. So if you are really interested into sports, this will be a great type of engineering to go into. Okay, so next we're going to talk about some of the responsibilities engineers have and types of engineering disasters and learning from failure. With engineering, you can change the world with it, but you also have to know the responsibility that engineers have. And of course, with great power comes great responsibility. And there is a certain type of responsibility engineers have when it comes to the health of the environment and also the health of other people. So the role of the engineer is to respond to a need by building or creating something along a certain set of guidelines which performs a given function. That device, plan, or creation should perform its function without fail. Because engineering usually involves in the creation of products for others to use, we have to make sure that those products are safe. So everything, however, of course, fails. So to perform its given function with a sought after level of performance, hence the engineer must struggle to design in such a way as to avoid failure, and more importantly, catastrophic failure, which could result in loss of property, damage the environment of the user of that technology, and possibly injury or loss of life. So what makes a failure into an engineering disaster? So much of the reason why we consider an engineering failure to be an engineering disaster has to do with the public perception of risk. So these are the primary causes of engineering disasters. So the sad part is that the highest percentage, 36%, is usually insufficient knowledge. Next is underestimation of influence. Then there is ignorance, carelessness, and negligence. Also for forgetfulness or some type of error. There's also relying upon others without sufficient control, objectively unknown situation, unprecise definition of responsibilities, choice of bad quality, or other. This is very important for engineers and also engineering companies to make sure they minimize the risk and dangers that people can face from these so-called engineering disasters. And ways to prevent this is, of course, proper communication between workers and colleagues, and also to increase knowledge of everything and make sure you always know what is going on, and also making sure that you're not working with faulty equipment. So, engineering is a very exciting degree to go into, and there are ways to prepare yourself for engineering. So, there is to learn coding, take science and math courses, more specifically calculus and physics courses, because all types of engineering include calculus and physics. And of course, gain as much experience as you can. And you can do this by doing engineering specific summer camps, internships, or research. So this is the end of this lesson, and thank you so much for watching.